in CI/CD, what the concept is this, that you should not have these 4 different stages. A developer can keep on working on their code, and they can keep on pushing their new fixes, new features in the main branch, as we say, and that automatically gets deployed on the production. All these stages that I have told you, right, they become a part of a process. So if any testing is needed, it becomes a part of the process. So, and this flow just continues as it is. That's a real what do you say, theoretical uh, CI/CD pipeline. Different companies will implement it in a different way. So an ideal case scenario is one thing, and the real case scenario is another thing. You might encounter where this entire CI/CD is not done. What do you say, in an ideal manner. You might have some parts of it which are automated, some part of it which are not automated, and so on. Okay. So these are 2 main things which you will be doing as a SRE and DevOps engineer. Git will come in managing your code, and understanding of Git is required to do your job well. Okay. No matter if you are in a pure CI/CD environment or you in a semi CID environment, you will need to use this knowledge. So this is what happens in a software application. So this particular diagram is what it is showing you, that more and more requirements are coming, which you have already experienced now, that there will be different teams who are, someone is working on the fixes, someone is working on the features, and there is a main code already running. So parallel development is taking place, and because of this parallel development, these kind of scenarios come. So this is a one scenario. At the end of it, what happens is that hairy changes are lost, because uh, both Harry, first of all, both Harry and Sally wrote on the same main branch, main repository, main code, and due to which, at the end of the day, Harry changes were lost. So we don't want to encounter that. There can be other such scenarios as well. There can be conflicts of the code, etc. But we have just given you one example to make you understand the need. So then we spoke about other ways you can do this. But what, at the end of the day, what we say, that we need a version control system, and there are many version control systems that have come over time. But what we are moving to right now is something called distributed version control system. This is the most appropriate, and this is what we are discussing right now. So as you also asked this question, in a distributed version control, what is happening is that on your systems, on your local systems also, right, you are maintaining a main repository and a feature repository or feature branch. Okay. So this server repository, which is the main branch, you can say, or the main code of the software, you can say, it is always synced with the local server repository or the local main branch. Okay. No one is making changes directly to this server repository. You always make changes to a local branch and then merge it with the server repository. And obviously, when you merge that, Git will all take care of this thing, that it has the latest code. Okay. So if suppose this particular code has changed and you will try to merge the local code on your system, it will not allow you to merge it. It will ask you to pull the latest code. So as we say, that always we will pull, we will merge, and then we will push. That is the process. Okay. This
Okay.
is a non-centralized or non-distributed version control. So here those challenges still can come. Okay. So this is again telling you this thing. Just go through with this PPT. It's a very self-explanatory part, that how this is working. So as I told you, if you will try to push it, it will not get pushed. You will have to first pull it and then merge and then push.
Yes.
This is the ideal case scenario, and then you always pull it. So the concept is that whenever you start working on a distributed version control system, obviously, if you are working regularly, then you will be in a habit of always pulling first and then start working. Okay. So that is something that you will create a habit of yourself. So another thing is that this particular part is more important again from the development perspective. But what you have to understand is that, as I told you, in your scenario as well today, so there is one production code that is already running, that is live. You are receiving problems from the customers every day. So your development team is okay, what do you say? They are selecting the issues that they have to work on, and these issues will become a part of the bug fix. Okay, so someone at your end on the development team end will be creating a bug branch or something like that. They will be pulling it from the bug branch, fixing it in the bug branch, and then moving it back to the main branch. That is one thing that is going on. Another thing that will go on is, again, feature requirements are coming from the customer side. Feature requirements comes from your product team also, who are studying the market, deciding what new features have to be developed. So again, a feature branch will be there. Again, different people will be working on that feature branch, and again, all those things will happen. So at a single point of time, this diagram is simply telling you this can happen. And what should really happen is that whenever we are working on our product, we should never be merging anything in the main branch directly. No code goes to there. Only it goes there to through a merge. Okay. So if I were to just read few lines from here, this is what is happening also. The code modified or created during the development cycle should be maintained on a separate branches. A second standard branch, often named dev, is typically used to maintain the code that is actively worked upon. So you might have heard this already, like there's a dev branch and so on. At the beginning of the cycle, the dev branch is identical to the master. So here you will fork it. Okay. During development, the branch dev will maintain the evolving code. So maybe one feature is coming, second feature is coming, one bug fix is coming, and so on and so forth. At the end of the cycle, the dev branch contains the completed code. So here you have all the, so when I say cycle, today you also know that we normally development teams follow your agile systems. So what they have is a sprint. Every 15 days, there is a sprint. So whatever fixes are there, they all go in that sprint, and they are, so that the cycle here represent that sprint. So this green color becomes that particular dev release, which has got all the fixes merged in it. And then you actually go and merge it into the main branch. Okay, and then the next cycle comes, and so on. Okay, so you have to keep this picture in mind when you are now working on Git, so that what